Now, what we're going to do in number 2 is we're not actually going to solve the whole thing. We're just going to investigate, can the mean value theorem be applied? So all that we're looking for is the function differentiable on the open interval, continuous on the closed interval? We already did this graphically. It's very easy to see if you see the graph, right? But if you're given the function, you've got to do a little bit of analysis. Okay, so let's apply that here. So we're not actually finding the slope and all that. We're just seeing if the mean value theorem can be applied. Okay, so we have these functions. We're given the intervals. The first one, x to the 1/3, that's the cube root of x. Is there anywhere where the cube root of x is not continuous? Is there any value that you cannot take the cube root of? No. So do y'all agree that the cube root of x is continuous everywhere, right? Okay, so I'm going to write that. F of x is continuous. Now it's continuous everywhere, but since it's specifically looking at the interval from -1 to 2, we're just going to say specifically on that interval. Check. Now, to determine if it's differentiable, we need to find its derivative and see if its derivative is continuous on that interval. So let's find f prime by doing lovely power rule. 1/3 x to the -2/3. If you rewrote that, you would have 1/3 x to the 2/3 in the denominator. Is f prime continuous on the interval from -1 to 2? Ooh, I see some differing answers. Ooh, I'm still seeing differing. Oh, I'm seeing a lot of this and a lot of this. You have an x in the denominator, correct? At what value could x not be? 0. Is 0 in my interval? Yes. So therefore, f prime of x is not, let's say, defined at x equals 0. So therefore, f of x is not differentiable on the open interval -1 to 2. So therefore, mean value theorem does not apply. Now, if I changed this to the interval +1 to 2, would that work? Yeah. But because the 0 is the problem, and that's in our interval, it cannot apply to this interval. Could there still be a value that the slope of the tangent line equals the slope of the secant line? Could that still happen? Yes, but it is not guaranteed. Okay. Questions before we go to B? All right, on B, is my function discontinuous on the interval? So yeah, it is continuous on the interval. The only place it's not continuous would be at 2. 2 is not in my interval, so f of x is continuous on the interval from 0 to 1. I don't know what I wrote there. 0 to 1. We can kind of make a note, discontinuous at x equals 2, not in interval. Okay, so we're continuous. Now let's see if we are differentiable. Differentiable, we're going to take the derivative. I'm going to rewrite 1/x minus 2. The way I would approach the derivative would write it as x minus 2 to the -1 power. I would not do quotient rule, I would do chain rule. So then f prime would equal -x minus 2 to the -2 power times the derivative of the inside, which is just 1. Oh, I kind of left off my equals. So if we rewrote this, we would get that guy. Is f prime continuous on the interval from 0 to 1? Yes. It also has the only discontinuity at x equals 2. So therefore, f of x is also differentiable. And when we state that, we're going to include the open It's differentiable on more than just that, but since we're only focusing on that interval, make sure you state it correctly.
Do you always use open brackets when you're talking about differentiable?
Yes, good. Always open brackets when you're talking about differentiable. Even if it's differentiable on more than that, you will still always use open brackets for differentiable. Yeah. Any other questions? I want you to try C on your own. I'll give you a couple of minutes to try C on your own. So see if you've kind of got what I've got. And then I'm going to pose the question to you. Is the function differentiable on the interval we are interested in? See how I wrote out domain, right? So you see the domain in each one. With the derivative, that square root becomes in the denominator, so 3 is no longer in the domain. But exactly what Arjun just said, to be differentiable, you do not have to include the 3. So you see how f prime is continuous on open interval 3 to whatever. And that's all I care about because I want ff to be differentiable on open interval. So at 3, the fact that the derivative doesn't exist at 3 is okay because I want the derivative to exist on open interval 3 to 7. So that one's tricky. So does everybody see now that f is in fact differentiable on open interval 3 to 7? Any questions on that? So that one was tricky. So yes, the mean value theorem will apply. So I forgot to do that. Yes and yes. Mean value theorem would apply to both of those.